Hello everyone, this is Aditya and today we are going to perform Professor Walter Lewin's experiment, and it will be a very simple setup. I have taken a rope and a ball to provide the weight, and I will place it near my chin and I will leave it. And let's see, will it come back to my chin or not? Okay, let's see. So this is the ball and I'm bringing it back like this, and now it's near my chin, it's touching it, and now I'm leaving it, and it did not touch my chin. You know why? By law of conservation of energy, it should have come to my chin, but it did not because of air friction. And now let's talk about it in a great detail using mathematical tools. Okay, so I hope you understood the experiment now, and now we are going to the mathematics. So now let's see the mathematical calculations of whatever we performed. But please do like and subscribe my channel. And now let's start. Okay, so the whole setup was basically a simple pendulum, right? So this was your rope and this was your mass, right? Okay, so there was some tension and weight, of course, but we are not taking that into account right now because we are only worried about the energies, right? Okay, so this was your reference point, suppose this. Okay, right? Okay, and yeah, I'm assuming the length of the ball negligible, okay, in this case for simplicity. Okay, so when I displace the ball over here from its mean position, right? This was your reference level. At this point u must be equal to 0, and over here, since it displaced by a height h, right? Okay, so what must be the energy is equal to mgh. Since it has no velocity at that point, I did not provide it any velocity, I just left it. So because of that, there will be no kinetic energy, because you know E is equal to u plus k. So it will have mgh potential energy plus half m into v square. But what is v? V is 0 in this case, since I just left the ball. It is similar to the case of dropping, right? So we get mgh. So over here the energy is equal to mgh. Okay, right? So now the ball goes from here to here, right? We are not taking this place into account. Okay, it reaches over here, but now the case over here is that it will reach some height h dash. Why? Because we are assuming that air friction is there, air resistances are there, so because of which some amount of energy, suppose 5%, just 5%, is getting wasted in the form of heat or whatever kind you want to say, right? So initial energy was mgh, right? But since 5% got wasted, which means the left out energy is 5% of mgh is equal to mgh dash, right? Since at this point also velocity is equal to 0, right? This is another extreme point. So when you calculate this, you get 95 by 100 mgh is equal to mgh dash, right? So h dash is equal to 0.95 of h, right? Okay, so now the total energy is 0.95 mgh at this point, right? And suppose when it reaches over here again 5% energy is dissipated in the form of heat, right? So in that case, what will be the final energy? It will be this energy 0.95 mgh, right, minus 5% of 0.95 of mgh. Will this be the case, right? Okay, so when you solve this, you get 0.95 into mgh into this will be 0.95 again, right? Of course the percentage can vary, I'm just giving an example to tell why it happened, right? Okay, so this is equal to 0.95 whole square into mgh, right? This is correct. Okay, and this must be equal to, suppose it reaches, when it comes back, it goes there and it comes back, suppose at this point it acquires a height h double dash, okay, is equal to 0 is equal to mgh dash double dash. So you get h double dash is equal to 0.95 whole square h, and if you solve you get I guess 0.9025 h, right? You will get this, right? Maybe calculation is wrong, but the concept is this. And this is just a random percentage. It's not like it is compulsory. This I just assumed for telling you the concept, right? And since the ball is going like this and then this, so that is why I left it from my chin, but it could not reach back to my chin, since the maximum height it could reach was 0.9025 times the original height. So that is why it could not reach my chin, and it stopped a bit earlier and it went back. Okay. So I hope you understood that why it all happened. Okay. And this is all just random data which I've taken just to explain the concept. Okay. So basically, but if there was no air resistance and I would be performing this experiment in the vacuum, then in that case there must be no dissipation of the energy. So in that case mgh must be equal to mgh dash and must be equal to mgh double dash. So h is equal to h dash is equal to h double dash, and in that case it must have hit my chin, but right now it's not possible. Of course, if I would have provided some velocity in the initial case, suppose it was mgh plus half mv square, right? Some velocity I would have provided, then there was a possibility that it would have hit my chin, right? So even if some energy must have been dissipated in the form of heat or whatever, suppose x% was dissipated, so we will be left with 1 minus x%, right? Okay, or 100 minus x, you can say 100 minus x%. This must be the energy which must be left, and when it reaches back, so it must be equal to mgh again. So there must be some condition for velocity. When you calculate this, you will get some values. Okay, so depending upon that, if you provide some initial velocity, then there is a chance that it can again come back to that position. Okay, but if you are just dropping it, then it's not possible because of air resistance. I hope you're understanding. This is a basic idea which I'm telling that why it all happened. Okay, so if you all understood this concept, then please like, share, subscribe my channel, and thanks a lot for watching it. Bye bye.